I'm posting on LinkedIn right now. Please hold. Okay. I did a live stream yesterday with a friend, Eric Smalling, and we had a lot of fun. So if you didn't know about that, you can rewatch. I mean, if you're just on one of my things, you'll get news about it. If you're on my newsletter, if you're here, you'll probably hear about it at some point. But we did this thing yesterday. Where is this at? It's over here. We did this yesterday. It was a lot of fun. It was almost like a mini course, I feel like. it was a lot of stuff. We covered a lot of stuff. I think I'm going to pin that. I'll pin that to the stream. Yeah, let's do that. All right. Today I am working on more GitHub Actions stuff. It's actually following up from yesterday's webinar and finishing up a couple of PRs that I want to do. This is all going to be stuff that ends up probably in my GitHub Actions course because I think this is pretty important. Processes. I feel like I need a diagram in here to describe this stuff. So I have this diagram here. Yeah. Probably need to make this better. Yeah. So this is what I'm working on right now. This is a workflow in GitHub Actions that it's a series of workflows that I honestly think most organizations need to either emulate or I mean, they probably can, it's more advanced than mine, but this is like bare minimum table stakes for GitHub Actions automation for any container related artifact that you're deploying to servers. So if you have compose files, Docker files, Kubernetes manifests, customized manifests, Helm charts, anything that you can, any cloud provider that where you're specifying image by tag or image names, I feel like these three orange workflows are necessary. And I have them in a repo. So this was a repo in the webinar yesterday that we talked about. It was like it was really just another live stream. I did a live stream yesterday with ChainGuard. And so we talked a lot about security in image automation because you can have the best, most secure image with no vulnerabilities today. But then if you deploy it in production and wait 30 days, it probably will have some sort of vulnerability in it because we will have discovered new CVEs. So anything in production for too long and you run the risk of there being vulnerabilities found, which means that you need to not only be rebuilding and redeploying images, but you need to detect upstream changes in things. And recently, I've come to the opinion that I need to tell more people about this silent rebuild. And really, I need to do a couple screenshots. But in this repo, we show an example. So this is a really cool, this is some really good stuff that Eric Smalling put into some Markdown. And what this shows is for a specific, it sort of proves my theory that if you're not pinning to digest and then looking every day for new digests automatically, then you're not technically using the latest image of whatever SymVer that you've chosen to use. If you have Postgres and you're using upstream Postgres images from Docker Hub, or if you're using Python or whatever, the version that you've pinned to, and you're probably pinning to versions, you might even be pinning to SHAs, But if you don't have something that's checking daily for a new SHA, then you're missing out. And this is a great example of, this is a little bit older of a Python version, but you can see that over the course of 53 days, this exact version of Python was rebuilt 9 times. Well, it was rebuilt 8 times after the original one. And you can see that the CVE count didn't really change for criticals, but it did for highs. It lowered the highs over time. Over time, it lowered the mediums. It lowered the lows. So you could argue that keeping up to date on this particular version of Python, for some reason, if you didn't want to move to Python version 4, then you needed to stay on this one, that you still need to be looking for digest updates. So this repo shows some open source ways to keep all of this stuff current. And you don't need much. You need either Dependabot, or you need Renovate, or you need Digestabot. There's actually 3 ways to do it. And this repo compares them a little bit by showing you, at least down here in the documentation, shows you a little bit of the features of the 3 and which ones support which parts of this solution, because it's not just about image tags. It's also a question of, can the tool detect the digest change for a tag? Can it properly give you pull requests into GitHub? And can it also ensure that the same thing, tag and digest, are both getting pinned for your GitHub actions that are running the CI that's updating your images? I just kind of feel like they're part and parcel. Like if I'm going to be updating images for security, the things that are running those update processes also probably need to be pinned so that I can feel secure, more secure about the things that are running the things that are updating my production. So I don't want gaps in my security when it comes to my CI automation and my CD. So I feel like you need to do both GitHub actions and all your image digests. And you can see that I've got some pull requests here. And if you've ever used Dependabot, you're probably very used to seeing things like bumping your GitHub action. And in this case, what I'm showing is how Dependabot can actually pin the SHA hash and update the SHA hash as well as the version number at the same time when it does updates. And all you need to do is in your Dependabot file, you can specify that you want it to update GitHub Actions. You can specify that you want it to update Docker files or Kubernetes files. Anything that has a Docker image or container image is considered the Docker package ecosystem. So, what's up, Yogesh? Sorry if I mispronounced that. What's your question here? Does it matter if containers with CVEs are not exposed? I observed that when CVEs get detected, they become high priority over everything else. If I say never fix something that isn't broken, in such cases, am I wrong? CVEs is not exposed. I'm not sure exactly what your question is on exactly what you mean by CVEs not exposed. Bottom line is in any production environment for a team, you're going to have more than a couple of images. You might be in a team where you're using 100 or more container images of varying types, databases. You got Redis, you got Postgres, you've got Elasticsearch over there, you've got Nginx proxies, you've got all sorts of things. You've got Kubernetes itself. You've got the underlying infrastructure that's running your containers. Depending on how much you're responsible for, you're going to have dozens, if not hundreds. The reality is that you will almost, unless you're just a small team of one and you have like one app and that's the only thing you have to maintain, and that one app is like 3 images, which is super rare. Like I rarely see that unless you're a hobbyist. You're not going to be able to keep track of all the CVEs that your images have, when there's new ones, when there's new fixes, what severity of which ones you have to, understand, and understanding the severity and when that particular vulnerability is exposed. Like in terms of when you say exposed, what I mean is if it's something that is in production and there's a strong likelihood that that particular vulnerability could be accessed. For example, if there's a vulnerability in curl and you had curl in your images, but you never directly run curl in your app, I would argue, why is it even in your images? But if you never directly run it, then you could argue that you might lower the severity of that particular one in your case. And then thus, if it was considered a high, you might internally rank it as a medium. The bottom line is the teams that I see and the teams that I work with do not have the kind of time on their hands to do this level of evaluation on an individual CVE basis per image, per deployment, per CVE. Like that's just we've moved beyond that because we get new CVEs every day. Image CVE counts in production change in your environments every day, and there is not enough time for someone to manage all of that. And if that's true, which in the case that I've been working with teams for decades now, it's almost always true. And at best, if they have someone is in a dedicated security team somewhere else and they're managing it, but they also struggle to keep up because they're scanning the hosts, they're scanning the containers, they're scanning all these things, and they're trying to keep up with all of that. And usually they're dealing with thousands or tens of thousands of vulnerabilities at a time. And you have to have a corporate policy. But the people that I work with don't individually worry about vulnerabilities until it gets to such a thing where it's a critical that is in production and it's like 10 out of 10. We've had that in the last 5 years. We've had, Heartbleed is an old one I can think of, but we've had Log4j. We had the Singularity attack that happened just a month or two ago. That was a pretty short-lived one because we reacted so quickly, but it was still a vulnerability that if you had downloaded the NX package, you were potentially running rogue code because there was rogue code in it. So that's a big deal. Like you don't want rogue code deploying with your apps. So that's a 10 out of a 10 in my book. Unless you have one of those, which is typically like 1, maybe 2 a year, you don't have the kind of time to manage all of these individually, which means you have to automate this to the point that you are deploying into production as fast as possible as soon as upstream tooling improves. As soon as a CVE fix and a new version of whatever you're using upstream has been fixed, ideally what you want is the robots to automate you a PR. Because the teams that I see and in my own work, the best daily task that I can do in terms of security is to make sure that I'm approving PRs for security updates. So I always want PRs there so I can approve it. I need to look at the change. I need to decide if the change is risky, if the change means I've got to change a major version of something, or if it's a big update, I'm going to be a little more picky when I'm going to look at the diff a little bit better. But what you need a set of automations, of which I have these examples here in GitHub Actions. A set of automations that ensure that you're using all the latest security updates for your app dependencies, for your image dependencies, and for your GitHub Action dependencies. You need something for all 3 of those, and it all needs to be automated so that you sit down at your desk at the beginning of the day, you've got a list of CVEs as PRs. You can see them, good examples here. I've got a list of updates. And the reality is with your app dependencies, let's say you got a Node app or a Python app or a Ruby app, whatever. Your dependencies in the app will often be CVE related. So you'll be able to go, oh, this particular app has a dependency update because a CVE was found. So that's a security update that Dependabot will do for you, or Renovate. Either one of those two tools will do that for you. So that's a bare minimum. Most people are doing that. Most teams are doing that in GitHub or GitLab or whatever. They are automating these application dependency updates, particularly for security. But if you're an infrastructure person, your level of concern is typically the image artifact. You're dealing with image updates, not so much the developer's app updates. You might be related to them, you might be in the same team with them, but if you're pure infrastructure, you concern yourself more with the artifacts you're deploying, not so much the apps and their dependencies themselves. So when you're dealing with this stuff, you typically deal with image from statements or Kubernetes image values of various things you're deploying. You might be deploying proxies and databases and all that kind of stuff. So you track those hopefully in GitHub. You're using infrastructure as code, and you're tracking it in your Git repo somewhere. And in my case, I've got a bunch of examples here that I'm building out. And so I've got some very simple Node apps here, and there's nothing. I don't really need to show code because I'm showing how, for an infrastructure person, all of my concerns are for the upstream images. So I care about the froms in my containers, the official images that are being used. And then when I go into my pull request, I got a snoring dog next to me. When I go to my pull request, I am seeing updates that show me that it's automating the updates to my images. And in this case, I've specifically designed Renovate. I'm using Renovate in this case. I'm specifically configured Renovate in this repo to give me SHA hashes for all version updates. And in this case, I've also told it to always keep me up to date on the minor and patch versions of my images. Not the major versions. I don't want Renovate to change major versions for me. I'm probably going to move those myself. And that's up to you whether or not you want these patch systems to tell you about major updates to Symver. So I configured it to only do minor. So then it's telling me, hey, there's an update for node 24.0.0 to 24.10.0. And it gives me the SHA hash, which I want. I want to be cryptographically guaranteed the exact image that I tested. I want the production to deploy exactly the image that I tested and PR'd. And the only way to do that is through a SHA hash. Because as we can see back in the code, if we go into these digest counts, if I go look at Nginx, I can see here that for every version of Nginx, that container image has been rebuilt many times, and the builds sometimes change the vulnerability count. So I typically want the latest. For example, this one has 2 less criticals than the one that came out when this version first appeared. So it's been silently rebuilt. That's what I'm calling it. It's a silent rebuild where no tag is changed, only the digest, but it's a new build that I need to care about. So my tooling runs every day. And if I go into the GitHub workflows, I can see that my Renovate is set to run daily at 2 a.m. I gotta blow my nose. Let's see, every day at 2 a.m. I am running this, and it's going to run my Renovate config, which is going to look for Docker files, Kubernetes files, Helm charts, stuff like that. And it's going to use this config in this directory. It's a pretty short config. It's only focused on Docker. And I add labels to the PRs. I tell it where to find my Docker files. And I tell it that I want it to separate out any patches for major versus minor. so that I don't end up with one giant PR that has a whole bunch of updates that include major versions and minor versions in one. I kind of want to break it out so that I can individually control them. I probably would want to change this to set it to one PR per image update, just to be very explicit about my pull request changes, because you can see here, if I go under one of these renovate ones, yeah, see, it's changed a lot of files. So the cool thing is, it will, if I just put Docker files in here, it will automatically give me, if I don't bother to go and pin to a digest, it will do that for me. So this PR detected that I added some files into my main branch, and they don't have SHA hashes. So it did that for me. It found the latest one, pinned it for me. I can approve this, and away I go. Now, hopefully that answers your question. Got to find my live stream here. Oh, I was hoping the question would show up in. It doesn't actually show up here. You have to go in here. Yeah. I have this new, I might be making a GitHub action, and I'm not even sure I really want to. I might be making a GitHub action that will take 2 gripe scans and compare them. And I'm thinking we are on the GHA scanner branch. This is what I'm working on. All right, so we are creating an action, and we are running a pretty long shell script. It's 170 lines of shell script to compare it's going to compare the diff. So I think that we are working on a PR for what are we calling this? Scan Docker file changes. We're using gripe to compare the digest changes in a PR. So we know if a PR will improve or worsen our CVE count. Please check this branch for the status, as I think we need to change this action to run on the PRs produced by Renovate rather than run this action along with those tools. Since those tools create new branches and PRs for the image digest changes, I think we should move this action to the Docker build workflow. All right, reading your chat. This setup looks amazing. In my case, created local Docker registry, and I have Docker Scout workflow, which decides the tag safe image latest. Next time it deploys, it pulls the safe image. I'm probably modify it like the SHA you mentioned. Yeah, Docker Scout is actually great at this. Docker Scout actually has a GitHub action if you're able to use Docker Scout. I'm not sure if it's a paid feature or if it's free, but Docker Scout has a GitHub action that will do this same thing that you can do in the Docker desktop. It'll do that in Docker, in GitHub, and it knows the difference between the images that you've deployed or the images that I think you can even have it connect to your clusters and detect those. It's pretty sophisticated. This is not going to do as much as what Docker Scout does, and Docker Scout even recommends images, which this little thing I'm building won't. It's just going to be very basic. What's up, Conrad? Welcome back. So yeah, this is, I don't know why these little chats windows keep changing. They keep changing sizes. So yeah, I'm doing this in Bash at first. I'm not sure it'll stay Bash, but it's there for now at least. And then in here, I think I need a new workflow. Yeah. So if you didn't know, I have tag and digest of the old and the new then pull and scan both and then show the results in the GitHub action job summary. So I'm going to make its own action. Scan both with, and these are Docker pulls. You've made a composite GitHub action for this, but I think we should now create a new workflow in that watches for pull request events and runs the tasks I listed. Let's see if that helps the AI change it. I'm not sure if that's going to be enough, but we'll do that. All right, so ideally we're going to have a brand new workflow. It's going to end up living in the workflows directory, and maybe it's just going to be called image let's see, not image change. Let's call it artifact. Artifact, it's just for container images, for image artifact CVE diff. Image artifact CVE diff. That's as good a name as any. Yeah. So it's doing a git diff. It's installing gripe. Find all change Docker files. Changed files. Please process each Docker file. Get the diff output for this Docker file. No diff content found. All right, so it looks like it's correctly extracting the old and new from lines. So it's using the get diff output to find the old and new. And then eventually it'd be ideal if we could check the formatting to make sure we've got the correct ones. But for now, it's YOLO. Okay, so maybe this is before and it's just printing out before and after images. Okay, so now it's going to Docker pull, and then it's going to gripe with a JSON output, and then it's going to parse that with JQ to find the diffs of the CVE counts, and then it's going to do the same thing again. We could probably save some stuff there if we reused all of that. We don't have to make it twice. And then we calculate the differences, and then we format things pretty for output. And then, let's see, critical. Okay, so it's doing old, new diff. This is pretty close to what we want. I'm not sure that it's going to need to change this. I hope it's not creating me a whole new workflow. So it built me this action. Actually, this is only in the branch. So if we're in here, it's got this whole new action that we just looked at. So I need to call that action. But what we did before is we were calling it, I think, from here. Yeah, so we don't actually want this to run here. We want it to run independently of this. The mistake I made the first time I did this was I thought this renovate would create changes. But however it's working, it's creating those changes in a way that this job cannot see those changes on the GitHub Action Runner. So every time I would run this, it would say no changes detected. So it could be an error in the script, but my guess is that renovate and dependabot do something a little bit different. And I realized that this is not actually the place to do it anyway. What's really the place to do it is in each pull request. So when I change the node version, like this one. This one's a single file change. It's changing the SHA hash. But if I went and scanned these two, I could put in a comment. Man, this is really slow today. Woof. So what we actually want, where do I have this? So in here, yeah, okay, here we go. I have a Peter Evans create or update a comment. So that needs to go into this new one, because I think I'm going to put all of that output into a comment in the PR, not just the GitHub action run. Because people that are looking at PRs to approve them are probably not going to go into each individual action run and look at the output. Like here. Actually, we had one. No, I can't find it. I don't know where it went. Okay, manually run. Oh, here we go. Yeah. So this was kind of what I was getting. This is the output I was thinking about, the comparison report. But it always tells me, oh, that's weird. Sending me to the docs. So this always produces nothing, no changes. So that's the problem with my design. All right, what have we done? What have we done? Oh boy. Dockerfile diff scan. Oh, that's a good name. Yeah, I don't need that. That's a little excessive. We do need read. That's good that it set that. I believe I have that in my agents file to always add permissions, necessary permissions to the workflow. And then, okay, so we're going to check out. That's good. Scan Dockerfile changes with gripe. Oh, yeah. So it created it all in here. Okay, so it's messing around with the bash syntax. This workflow triggers on PR open events and grants only read permissions before bailing out early if no Dockerfile changes. Within the bash script, the script compares the base and head commits, extracts altered from statements, fetches both images, records repository metadata, runs gripe, and writes a severity diff table plus assessment into the job summary. So I don't know why it didn't run action. .github workflows Dockerfile diff. Yeah, we're going to have to deal with that at some point. All right, so since it reproduced all of that, actually that action won't run. So let's do this. We're going to go into the workflows we had, and we're going to take out those lines. I don't know if we did it in here. Yeah, we did it here too. All right, so we're going to not do that. And I'm not even going to commit that. And then we're going to do this one. Yeah, fetch depth 0. Okay, so because it has to have a deeper fetch depth so that it can find the diff in the Git. All right, so we're going to have it pull all this out into its own action, but first, let's see if it runs. And by see if it runs, what we really mean is we're going to add that, and then, no, we're not going to do that one. We're going to do this one. Update, let's see. All right, let's go over to our actions. And so on this one, does this pull request change a file? I think it does. Oh, well. Let's take one of the PRs over here. This one right here. So this is node 24 digest Docker file. We're going to change out It's funny. It's funny. The two times it wrote this, it changed the emoji. Okay, so let's try this one. All right, so I changed the diff. We should see if it detects it. Come on, come on, come on, come on. What are we doing? Are we scanning yet? What are we doing? Let's see. It sees the diff. Okay, well, that's not usable in the logs. It's giving me some horrible markdown. I don't know if it's piping all, I think it's piping all of this into the summary. Okay, it's scanning the second image. All right, it finished. What did it put in the summary? Oh, I see. It thought that there's two images changing. So this is the one we care about. All right, so node change. Oh, this almost looked the same. 0625, 06E5. But they're different. They're definitely different. All right, so before and after. Oh, come on. All right, that's too easy. Let's take one that I know for sure would have a difference. Oh, and see, yeah. So this version. I need a bigger diff so that my CVEs add up. Let's see. I'm only changing. I'm just gonna have to validate this locally. We're gonna scan these ourselves. All right, so this is the one we're doing. Let's do this locally. So if we did Docker pull that. Gripe. And then we do a more, because it puts out a bunch of information. Okay. So that. So 1149. Just going to put that here for now. So that's the old image. And then, let's see. Let's get the new image. All right. Oh, I forgot the more. So let's see. We had 1149. Oh, you know what I could do is I don't have to change digest necessarily. Oh, see, this has only got 842. 832. So this is definitely different. Yeah, it's drastically different. So my script sucks. My script sucks. AI is wrong. All right. I wonder if this would work locally. Act, job. Let's see if that actually works. Line 27 code. Yeah, let's just take that out of there for now. Failed to match workflow job secret mapping. Let's see. GitHub workflows. All right, let's try that. Job scan Dockerfile diff failed. What's that? Failure main scan with correct exit code 1 failure. Run. That tells me nothing. So maybe act isn't the best thing to do. Let's see. I'm going to actually... Yeah, we're going to need to pull that script out and have it as its own shell script to run. That's really only the only sane thing to do. I think putting in the workflow is insane, and I'm not a fan of that approach. But I might, just for simplicity's sake, I might want to change this pull request so that it doesn't actually change 2 files, just 1 file. It's a little complicated when it's going through 2 files. All right, so we're adding this Python 1. set E, that failure bubbled into our helper. The echo fallback returned an empty payload in every severity bucket. Updated the helper so that scan runs. Gripe. Allowing us to keep the JSON output while avoiding the failing exit code. All other logic stays the same, so the summary tables will now reflect real counts, even when both images contain vulnerabilities. Okay, Mr. AI, you claim. Okay, what did you change? So you do gripe scan. That's it? You changed one line? All right. And I'm also going to delete. There's a Python one here. Let's say also ensure the script accounts for new Docker files that show up in the diff. We don't want to scan the before for that since the file is new. Can we avoid new files and only run this script on changed files? And then, yeah, so this will technically be my test of a new file. Can we, all right, we're just going to commit this. All right, let's do it. You never know. You never know when a workflow is going to be done. You run it. Act isn't great locally running GitHub Actions. So it has a lot of edge cases that seem to not work well and require me to add in environment variables and secrets manually in order to get them to function. So a lot of times I just push it to my branch in my PR, and I end up with a giant set of commits in the PR, and then I squash that PR merge. It's not beautiful. It's not ideal. It'd be better probably if I was running Dagger and I was doing it all locally, and then I could implement that. But all right. No CVs detected. Okay. It's still not working. All right, let's ask it. Could we move this script to then please ensure. Then we can test running the script locally without needing GitHub Actions. Is there a way to write test cases for GitHub Actions like one would write for code? Absolutely. I mean, if you're writing your own actions, a great question, Conrad. If you're writing your own actions, then it's really just code until it's run, like as an action step. So in repos where there's just all this code that is wrapped up into an action, actions can run multiple ways. One of the ways they can run is a lot of action steps will just be pulling and running a container image. And so that container image just has a series of inputs and outputs. And so you can test all of that core code if you're writing your own action. If you're like me and you're building an action out of a combination of things, you can use act locally, but like I just said, it gets kind of tricky if it needs secrets or environment variables that you don't get locally, because you won't have your GitHub Actions secrets or environment variables flowing down from GitHub into your local act, because the act is like the one way to run. So it just kind of depends on what you're trying to do. In this case, I'm trying to pull out all of the functionality of what it's putting in the workflow and just put that into a shell script so that I can then test that locally, and it wouldn't need an action to run. If you, like, I have a Docker build workflow that, because I'm on ARM and because act only runs Intel or AMD 64 based images, act doesn't work as well locally because it's pretty slow. It has to run through QEMU. So I haven't really come up with a solid process for exactly how I test things other than to push them to my PR branch and see if they work. Like I do spend, and this is probably my own fault, there's probably better ways to do it. And I think as a part of the troubleshooting sections of my GitHub Action course that I'm building, I probably will invest some time in looking for the latest methodologies people have for testing GitHub Actions. So in my case, like I'm looking here and in my code in this branch, I have GitHub Actions. So I have like this renovate one, and it runs this action, and I don't really have an effective way to test this locally other than to try it in act. And if act works and it runs, then I don't worry about it. Like I'm like, okay, it's probably good. I push it up as a PR. Half the time when I try to run it locally with act will bomb because it needs something that I can't give it in the moment. Like maybe it needs access to a pull request to check something in the comments because it's meant to scan that. It needs something from GitHub, and that may or may not work if it's outside the context of a runner. And it wouldn't be a bad idea for me to create a set of, if you're trying to test this, do this. If you're trying to test, building your own actions, do this. If you're trying to run a series of actions in a workflow and test them. But ultimately, everyone I've seen, like, you just have to write the workflow and push it. And then you set it up on a workflow dispatch so that you can run it manually. And then you just sit here in here, and like I go into this one, like if I'm changing something, and I just run it, and I pick my PR branch, and I just run it manually. So this muddies the waters if someone else is like staring at GitHub Actions, if they're staring and they see. That's why it's actually pretty important to see this branch here because if I'm someone who's looking at official stuff, like I want to know what's going on in my GitHub Actions, I want to see if things are running, I will ignore anything that's not in my PR branch or that's in the main branch. It just depends on what I'm looking up. So I don't really consider it rude or unnecessary. What it does is it adds delay, because it takes about a minute between you pushing a commit and it's spinning up the runner and then cloning the code and then starting your workflow. So it is a tedious process. You can try to improve this by having it run on a runner, and a runner that you manually select. and that runner could be on your local machine. But that's not going to save you a ton of time because it still has to go through the GitHub API and then get processed by their job engine in the background and then get execute or pushed to your. It's just it's one of those things where I wish Act was able to handle these edge cases better, and I wish I had a better way to run them locally. This is honestly like an entire advertisement for using Dagger, but I'm just not using it yet, and in this case, I'm just doing pure GitHub actions. So I think in this case, my workflow is really just a shell script that outputs some markdown friendly stuff. So let's see what happened. Oh, we're in the wrong one. This one. Did we push? That was 8 minutes ago. We need to manually rerun it, maybe? Oh, you know what? Right. We... Now it'll run. Okay. Okay, so it's running. Oh, nice. Okay, so it's pulling in ENVs. So unfortunately, okay, so it's doing base and head. So I could run this locally by emulating the SHAs. I would like it to do that as a part of the script though. So that script lives. Yeah, so I don't know locally. I don't believe your local Git has reference to PRs, but it could use the. I'm not sure if this scan would actually even work locally. I almost feel like this is okay. So this is scanning in this is scanning locally. So we have these events that, or these environment variables that exist in the runner. Goodness, excuse me. This exists in the runner, but these won't exist locally, and they may not exist. This is the problem with Act. Like, this may not exist if I try to run this in local Act, because these only work in the context of a PR branch, not just any branch. And the question is, if I run it locally, does it know that? Oh, you know what? It needs to be able. Doesn't it need to be able to write to the? Let's see. No, still no CVEs detected. Arrgh! So it's detecting the images. It's clearly got something wrong with the logic. Oh, good, Conrad. Yeah. So you're using my GitHub, my Docker build workflow as a starting point. I'm actually getting ready to improve that, by the way, in case you're curious. Let me give you a pro tip on this. Where am I putting this? We have it in the Mastodon. GitHub.com, Bret Fisher, Mastodon. Something I've wanted to do, and I'm not sure I've done it in the actual repo that you're using, but Eric Smalling and I worked on this Mastodon for our workshop yesterday. Goodness. It's weird. Is there a pull request? Oh, I haven't committed it. All right. Okay, so what I've done is I don't like using emulation for cross-platform builds, especially now that GitHub has ARM runners as well as Intel runners, Mac runners, Windows runners. And so in this case, most of the time I want to build AMD 64 and ARM 64. In the case of Mastodon, doing that with the default GitHub actions causes it to take 45 minutes to build the image through QEMU emulation of AMD 64 on top of an ARM 64 running on an Intel or AMD 64 runner. So what you really want is ideally, because GitHub Actions now supports this, I want to set up a matrix in the job that will split up the job of building these containers into an Intel runner and into an AMD runner, which are native and fast. And then it builds those two on two different job runners. And then it brings them together for the manifest that needs to combine both. When you push a Docker image, you need to have all the builds ready or at least the manifest for all the builds, and then push it all at once, because you end up in this thing what's called the manifest of manifests. So when you do a Docker pull, you may not realize, and you probably do, but the others watching maybe don't realize, is when you do a Docker pull, the first thing that's pulled is a multi-platform manifest, which is usually there. And even if it's just one platform. Actually, sudo bmitch, if he was online, would probably correct me. But it pulls down this manifest that tells you, hey, your machine, you're wanting to run an ARM or an Intel. Let me get you the digest for that image, which is a different manifest file that you have to go find. And then that one has the platform specific layers and image metadata for that image. Because technically they could be different. If you're building when you build these images on different platforms, they are different build executions by build kit. So they're technically completely different. So they have to have their own manifest, and then there needs to be a manifest that brings them all together under one tag. So that way, when you do Docker run node on an Intel machine, it works. When you do Docker run node on a Mac, it works. I mean, it works everywhere because Linux / ARM64 or AMD 64, like those things are all in the metadata. So it's meant for us to be easy as users, but when you're a builder, it gets a little more complicated. So I typically just run the default Docker build, and then I specify the platforms. When you do that in GitHub Actions, it's inside of BuildKit. And we won't get into the fact that BuildKit can actually distribute your builds. It's very intelligent, but that's not the way we really do it on GitHub. The way we're supposed to do it on GitHub is we tell GitHub, hey, this job goes on an Intel runner, and this job goes on an AMD runner. ARM runner. ARM runner. AMD and ARM live in my head in the same place, so I often get them backwards. So this particular, let's go to code and go to, what was that branch called? What was that branch? Branch, Docker build branch. So in this branch, under GitHub, under workflows, under Docker build, I believe this is a working prototype. This is all, by the way, shout out to Crazy Max. This is all official documentation from Docker Hub. GitHub Action Multi-Platform. There's a dedicated page, and I bet you Crazy Max did all of this, but it shows how to build and load multi-platform images in GitHub Actions, and you distribute the builds across multiple runners. And this is pretty dope. I don't know a lot of people that are doing this out of the gate. Like usually you learn this problem later, you get frustrated with how slow your builds are, and then you think, man, this is really slow. I wish I could use the runners natively so that that the processor matches the Docker build architecture. And it turns out you can. And you just need to start with a matrix. You tell it which platforms you want to use. And then you create a little environment variable to fill in later so that down, because I did this matrix, by the way, what this actually means in GitHub is that it will spin up 2 different runners, and it will run this on each one independently. And this, where's the platform? Where's the platform? Somewhere it tells that. It might just need, it might be all it needs is right there to tell it. Yeah, I think that must be all. So it's going to run this entire build. So I guess it's effectively ignoring this. Oh no, it's, well, I'm having a hard time understanding exactly how this works. I guess there's a native feature in Matrix platform. So GitHub Actions Matrix platform. Okay, so yeah, so nope, there's no arm there. OS. So it that means something. So that's like a special, yeah, because you can have all these different things. You can put whatever you want in the matrix, and it'll run once for each type, or each value rather. So this OS one must be some sort of, okay, so runs on Matrix OS. Build and load, yeah. Okay, so we start at the top. You can build multi-platform images using the platforms option, as shown in the following example. So I think this is the right one. Build and load multi-platform images with Bake. Okay, so this is the one I was using. So we've got Matrix platform. Platform pair. I don't exactly know how it knows to start a new runner. It's a little confusing to me. But the point is, I think it works. And then what it does is actually technically runs 3 jobs. It runs 2 jobs in Matrix at the top. It builds the image for ARM. It builds the image for AMD. And it does those 2 in this job. Then they output the metadata that is needed to combine these images. So it spits out and uploads this metadata in a way that the next job, known as merge, which needs that first job to finish, so that's why it has a needs in it. And then it does the combining. So it doesn't build anything in this job. It simply takes the metadata, downloads the artifact metadata. It uses the fanciness of BuildKit. This is just setup stuff. It then it's going to make all the labels and the metadata for the main image, and it's going to create manifest lists. So it's using the Docker BuildX image tool command, image tools, create, and then it's going to join the metadata output of these things in a wonderful little 2-line shell script. Well done, well done. Nothing too fancy. And then it's actually going to do an inspect. Really, I don't know why it's doing that. I guess it's a validation step to make sure it works. And I guess, let's see, this metadata action. Okay, so it's doing a push. Oh, okay, so it's actually a one-liner. It's just wrapping it. And so I guess when you do an image tools create, it actually pushes automatically based on the tags and the registry that you gave it up here. So that functions in my... So I have this set up. I don't even know why I have QEMU set up. I don't need that. I'll probably remove that and see if it still works. So we do the same thing here. We actually do all this, and then we export the digest and upload them. And I think even Eric fixed it. Yeah, Eric fixed this. So I'm going to... At some point, I need to incorporate this into the upstream Docker build stuff. So over here in this build workflow, this Docker build workflow thing, I think it needs to go under here. So where it's reusable Docker build, when you look at this one takes all of the... This one takes these platforms and it uses QEMU. So all the platforms you put in there, whether it's ARM v7, ARM v6, i386, there's a dozen different platforms. And down here in the job, it's relying on BuildKit to do this work. So in this step right here, this is where, in my current iteration of this is how it will build this out. So I think maybe I'm going to leave this one, and maybe I'll make some comments at the top that this relies on QEMU to function, and that if you would like a more native way, if you're only building Linux ARM64 and Linux AMD64, if those are the only two platforms you need to concern yourself with, because this won't work with other esoteric platforms like ARM v7, because GitHub Actions doesn't have a runner type for ARM v7, although you could technically run it on ARM64. It probably would emulate faster running old ARM on a new ARM, but that's a pretty more advanced scenario. So maybe what I would do is I would call this reusable. I'd make a whole new reusable workflow, and I'd call it reusable native multi-arc Docker build. It's a really long name. But I probably need to start a pull request here. I also need to update these. Yeah, you try to create for ARM and Intel. So let me give you this. Try looking at this workflow. I think as it is in its current iteration, it functions. It's not reusable yet. There we go. So I'll give you a link to that. And that might help you adjust your workflow to get native results. Now, if you don't have speed issues with QEMU, and not all apps do, and in fact, depending on the programming language you're using, you may not even need it this way. For example, if you're using Go, I think .NET is the same way, then when you're doing those platform programming runtimes, when they want you to build or run or create the container images, they want you to do it natively. They prefer it that you build natively on AMD 64 or Intel x86. They want you to build on the native x86 platform, and they themselves will emulate their builders have the ability to output an ARM binary or an ARM variant. And so depending on what programming language you're using and how your Docker file is designed, you may not even need this step. It actually comes down to depending on the language. That's why this stuff gets so complicated. Because if you go read the .NET documentation, what they want you to do is always do the Docker builds on x86 64. And then you tell the engine, the .NET runtime, you tell it what output platform architecture you want it to build for, the target. And it will do that so that you never need to worry about multi-platform building in your runner. You don't have to build multiple runners. You can just do it all in a single one. And that, I actually think, I have in a different repo, a different example, where I talk about, I haven't looked at this one in a while. I think this let me just search multi-platform Docker builds. I don't know if, Conrad, you have seen this repo. I will give you this repo as well. That multi-platform repo gives you a little bit more than you need. It gives you some guidance on how to build Docker files that will work across platforms and across different architectures. And part of, I don't know if it mentions .NET in here. Nah, I didn't mention that. But in case you get a little bit stuck on that, you're probably already doing it all now, so you probably aren't stuck. But what the reason for this repo existing is that I was trying to take a design that someone else had created, and they had created a Docker file for each platform. Each architecture had its own Docker file. And I wanted a single Docker file to run them all. And if you're using these arguments, these are built-in arguments for Docker. And if you start to use these, you can learn how you can target particular platforms when you're building with Docker. And Docker will use QEMU, or it kind of knows, based on the environment variables you set, how it's supposed to behave. And there's a lot of complexity and subtlety in some of this stuff. And so I had to break down all the different edge cases. And this is really just a blog post that needed a few examples, and I just turned it into a repo, really. I don't know that it even has much code. I think it has a couple of examples of Docker files, but I think this is one where you can run it and it will output some things maybe. Actually, that's maybe not true. That's just an example of how to build multi-arch. But what it really deserves is if this repo went to its fullest iteration, it would have examples of different programming languages. Like, Go builds multi-arch different than Python and different than .NET. And they're all have a little bit of their own language preferences when you build them. For example, if I go like .NET multi-platform Docker builds. It's not really talking about that. Maybe this is it. My dog is over here snoring. Docker makes it straightforward to build container images for targets that target a specific hardware architecture like ARM and x86 or x64. This is particularly useful if you have an ARM, M1, M2, M3 Apple Mac and want to build containers for an x64 cloud service. We are encouraging a new pattern for building container images for multiple architectures. It has better performance and integrates with BuildKit build model. See, this is new. I think my repo is older. Yeah, this is 3 and 4 years ago. This blog post was updated to reflect the latest releases. Okay, so this is updated 2024. So this is the new way. This post is focused on building container images with Docker build. You can also build container images directly with the SDK. Yeah, if you build problems to solve. This is the problem I was trying to solve. Many users build x64.NET container images on ARM64 hardware. Doing that can result in the .NET SDK running on an emulated environment through QEMU, which doesn't work well. You can see in the following screenshot that .NET Restore is taking a very long time to run with emulation. The pattern described in this post avoids the problem. You can use Docker build with a multi-platform friendly pattern. It has two aspects. Use the -- platform switch with Docker build, which you already would be doing, to target the alternate architecture, and then use these environment variables in your Docker file. Okay, so they're actually switching to the Docker way of doing things. This pattern can be used with any .NET version. In particular, we added support for .a to support Docker's target arch values, which are really Golang processor architecture values and different from .NET ones in the .NET 8 SDK. Okay, so this is really what changed for .NET. And what's the date? Okay, so that's 2023. This is after I made that repo, which I think I made that repo in like 2022 or 2021. And so before this fix, they were telling you needed to give particular build values in your build statement, but now you can do this target architecture. And if you do this in your Docker file, then no matter what architecture you run it on, it will build for that architecture, which is cool. Well, okay, this is the meat of this. Multi-platform. There are two really different scenarios at play here when I'm calling multi-platform. Build a container image for a specific architecture different from your machine, and build multiple container images at once for multiple architectures. We assume the user is using an Apple hardware, and in fact, I'm on a MacBook M1. Docker has a platform switch that you can use to control the output of your images. Yeah, the first takeaway from the analysis is the -- platform is always set implicitly as your machine platform, or explicitly if you put it in the command line. The bigger point is that the platform affects multi-platform targets like Alpine and the configuration of the final file. This platform value. Yeah. Yeah, look at that. Yeah, this blog post is basically going through what my repo. Hopefully my repo helped them, because I couldn't find very clear examples and stuff in the docs back in the day. The docs might be better now, but 4 years ago when I made that repo for multi-arch. Okay, so this right here, we can build Docker targeting x86 on ARM. We're now going to look at how to build .NET images using similar techniques to what we just looked at with Alpine. Right, there are a few characteristics that we want, and this is one I agree with. A single Docker file should work for multiple architectures. The results should be optimal, and the SDK should always run with native architecture, both because it's faster and because the .NET doesn't support QEMU. So this is why, okay, so this is the problem that I was getting into, was that when you build multi-arch on Docker desktop or Docker or anything with BuildKit installed and QEMU is enabled, when you build those multi-architectures, it will automatically use QEMU for anything other than your default architecture on your machine. And since the SDK for .NET doesn't support QEMU, the way I thought it was being done before, and we haven't gotten through this post yet, but the way I thought it was being done before was, that's why you had to tell the .NET SDK which platform output you wanted so that it had its own internal ability to build for that platform. We'll use a Docker file. This Docker file has been updated for .NET 8, both enabling non-root hosting, which I don't know what that is. Non-root meaning rootless containers, and multi-platform targeting. There are a few lines in this Docker file that will do something special that helps us achieve those characteristics. So we're going to use the platform flag anytime we build inside a Docker image. So the from line is going to have the platform. The Docker file format enables specifying the platform switch for a from statement and to use a built-in arg to provide the value. Yeah, so we're using the build platform built-in argument and the target arch built-in. This pattern doesn't actually require .NET 8. It works with any .NET version. In fact, it will work with any multi-platform tag, like for Node.js or Java. It's just a Docker feature. And we're now restoring and publishing the app for the target architecture using another built-in argument. Underneath the covers, the SDK is creating a runtime ID. That's the same as specifying -r argument. The -a argument is a shortcut for that. Some NuGet packages include multiple copies of native dependencies. By publish an app as RID specific, you will just get one copy of those dependencies, reducing your container size, matching your target environment. If you're building an Alpine image with this pattern, make sure that you're using the Alpine-based SDK, right, because you need Musel. So that's there, yeah. The second and last from statement is a multi-platform tag. It will be affected by the platform switch. And now this is a long post, but now we build multi-platform images, Docker, buildx. Yeah, so we're showing how to build this in a one-liner. Oh, and then it's telling you, yeah, you got to use the containerd image store if you want to store multiple platforms of the same image in your image cache locally on your machine or anywhere you're building Docker. You have to tell it to use the containerd image store. The original, up until very recently, the last couple of years, the original image store for Docker could only support storing one platform for an image at a time. So if you were to download the ARM variant of something, it would be in your image cache. And then if you were to download the x86 version, it would overwrite that. And it sucked. You had to toggle back and forth. But the containerd image store allows you to store both. And before that, like you may wonder how would that all have worked then? Because how would I have built multiple images locally? And the trick that they were doing in the background of Docker was they were building everything in BuildKit, which doesn't use the image cache when it's building. It's just building, and it's separate. And the image cache is over here. And so BuildKit builds, and then you would notice it calls a publish local is kind of what it does. So it publishes the image to the local image cache when it's done. But it would only publish one architecture, one platform variant. It couldn't do both at the same time. But now it can, at least is how I understand it. And now with the containerd image store, it allows it to do that. All right, so this is a pretty detailed post. This is a pretty good one. I need to put that out there. This is pretty awesome. Can I like it? Do I have to sign? Oh, I have to sign in to React. Okay. back to our problem. I wonder if I can steal, let's see, let's run this locally. I'm going to steal from my base. Let's look at the output. All right, so it's giving me the before and after. So if I do that, so if I run this script, scan, and then base is that, and then this is the after. It's base and head. Is not a valid get. Okay, so it needs a get reference, not an image. Oh, here we go. Comparing. Can I do this? Does that work? Yeah, okay. Okay, yeah. Cool. So what I actually need here is just the get diffs. The get SHAs. Head. Oh, shoot. I don't know which one is head. Let's just try this. Map file command not found. Line 232. Oh, well, the map file command doesn't exist on my Mac. I don't know. MPFI? Multiple precision interval arithmetic. I wonder if this is like a common Unix utility that there's probably a package that has map file. Map file on Mac. Oh, map file is a specific. Custom shells. Okay. All right. Yeah. Which bash? I think I'm using default bash. Brew info bash. 5 not installed. Brew install bash. Probably won't be my default though. Mm-hmm. Opt homebrew bin bash. So I could tell it that I don't want to use that command, because this is bash. I'm trying to remember on a Mac. I really should just run all this in a container. This would be so much easier. Adding the homebrew bash to Etsy shells. This step allows the system to recognize the homebrew install bash as a valid shell option. Changing your default login option. I don't want to do that. Etsy shells. Does it go in order? What could go wrong? Sudoing copy and paste from the internet? Does not pick between two band or it purposes to set those are considered valid. This is let's use various. To explicitly choose one of the well, what if I do? I don't think so. How do I get? This is a Linux command question. How do I ensure bash shell scripts use my homebrew bash? Yeah, I don't really add the shebang line to your script. Do I really? I don't really want to. I want it to be used as the environment. Make the script executable. Before running the script, ensure it has executable permissions. But my script uses env. To ensure your bash script is using the home when using user bin env, you must prioritize the homebrew bash executable in your shell's path environment variable. Yep. Okay. So in my path, this has gotten such a down a freaking rabbit hole. Okay. All right. So we're going to get out of here and homebrew. Okay, so opt homebrew bin is before user local bin. All right, so this should work. This should work. Cool. Okay. So try that. Oh, yeah, baby. Still, no CVEs detected. I'm still receiving no CVEs detected when testing locally. Can we output detected CVEs during each scan regardless of CVEs detected? I'm going to pin this. Okay, updated the script, added troubleshooting output so every scan prints the raw severity totals before the change table, even when gripe reports 0 findings. Yeah, see, it's not. The gripe scans have many CVEs, but the script output claims everything is 0. Come on, Ad, you can do it. You can do it. You can do it, Codex. You can figure it out. Don't make me go and edit that shell script myself. I thought I was going to do this in Go. And I may still do it in Go, but I thought if it could be an easy enough shell script, then we'd be all right. We could handle it. Yeah, so it's doing, I want to see, also, please show the exact commands we run in the output so I know the git, the docker, and the gripe exact commands the script runs. All right. It's troubleshooting, and I don't know what it's doing. It could be erasing my hard drive right now. I don't know what it's, when it says troubleshooting, what does that really mean? Is it running code in the background? I am not a Codex user. It's actually my first week with Codex. I'm more of a Warp terminal or a Claude Code or a GitHub Copilot. I have this over here going, but I haven't been using it today. So that's for later. We're not using that today. It's changing JQs. Yes, I've done the same. Yes, I know. It's not always obvious for the map selects. Yes, yes. Oh, we are adding mini dots. We are adding dots. More dots. More dots. More dots. More dots. Adding some more dots. I'm cleaning up how severity counts are processed by uppercasing values and mapping unknown severities. It really doesn't need to be this hard. I don't know why it's making this. It doesn't feel like it needs to be that complicated. All right, now we're updating some printfs. What? IDX +1. Okay, we're changing some more of the script. Running git status. I'll wrap up by explaining the modifications. The helper now exposes raw severity data so you can troubleshoot why totals come back as 0. Added utility functions that count raw matches. Bucket severity cases. After each scan, the script always prints before and after match counts. Try rerunning. We need multiple codexes running. This is taking too long. All right, so under scripts, we have this thing. It has 388 lines now. So much for simple, brah. So much for simple. Okay. Why build a shell script in 100 lines when you can do it in 400? Fixing indentation in loop block. I'm pretty sure there's some deduplication of code in here too. This is some complicated bash. Script now emits the exact commands it runs and surfaces richer scan diagnostics so you can see what Gripe is doing. All right, let's do that. And still 0. I feel like I need to start from, I think I just need to delete this script and start from scratch. It is not getting better. Let's see what we got. Let's see what the raw output shows. Git fetch, git diff. It detects one changed Docker file. So the git detection is working. It's catting a file. It's diffing. It's change before, after. It's pull. Oh. It can't do that. It can't pull both images. I think, actually, maybe it can. Maybe it can. So, okay, so this ends up with 3 images that don't have a tag, which is fine. It's going to use the image digest anyway. So 0625 and 06E5. Okay, so it's got both images locally. So it actually can do that because of my containerd image store. Maybe that's not, no, I don't think I need a containerd image store for that. That's okay. As long as there's 2, they're not, it doesn't ignore, it ignores the tag. So these are fine. It ignores the tag. This markdown is useless. This markdown table just needs to go away. Gripe return no payload. Okay. That's the problem. Gripe return no payload. So if I do this, fail on severity value none. Bad config. I don't even know what does fail on even do? Set the return code to 1 if a vulnerability is found with severity the given. Okay, so fail on shouldn't even be in there. It's about severities. Given severity. So that's for like if you want it to fail out of a workflow because you found a critical or something. File to write the default. We probably should have it writing these to files. Okay. Stop. Stop. If I do a -q, does that still output the JSON? It does. All right. So if I simply, what if I just change the script? I'm going to brute force this since it's hallucinating a little bit. Okay. So gripe, we don't want this. Let's try it again. Yeah, so it's going to take a minute. That was the problem. Like, this isn't going to, I'm not, if it returns instantly, then it's clearly not running a gripe correctly because gripe rescans every single time and it takes a minute. I wish I could tell gripe to only output the totals and not the giant JSON output that it does. Okay. Ooh, okay. Let's look at our totals. So we went from 42 to 6. It says 40 to 6 here. But, high. 231 to 106. I don't know where it's getting these numbers. $832, $1149. Okay, so it's got those totals correct. So I think one of the things is I have these backwards. So base is this. Head is that. And when I look at the shell script, JQ, so it's under matches vulnerability severity. Is it adding them up? All right, please design the gripe commands to save files like see base, date, time, and head. And map matches. So if we just do this goes to file. Okay, so we just do a file. file output. He's got his bone, his yak stick. All right, so this is actually not the base one. This is the head. But anyway, so yeah, an 8 meg JSON file. Okay, so my Vim is frozen. So let's JQ. Oh, does it have pagination? Indent, unbuffered stream. So matches. So I wonder if it doesn't add totals to the JSON output. Ooh, I can make a Go template to define a custom output format. The JSON output provides all the available data, which can then be processed by template to extract only the information you need. This is what we need. Yep. Use Go's template syntax to loop through the vulnerability counts by severity and print the totals. All right, let's try that. Let's try that. What are we going to call that? Summary TMPL. And then gripe. T. Template. All right, maybe we're getting somewhere. You know, we never did check the GitHub Marketplace to see if there was already an action that did all this. CVE compare. Okay, what about CVE? KSOC scans for CVEs in your images as part of your GitHub Actions CI workflow. Let's check that one out. This action checks if any CVEs were modified after a certain date. Check vulnerabilities in multiple repos. Yeah, so there's very... Okay. KSOC scans for CVEs in your images as part of your GitHub Actions CI workflow. Using gripe to scan for CVEs in given images, build a local image and scan it for CVEs. It will fail the workflow if any CVEs with medium severity is found. It will ignore CVEs with ID default output format to be used table. How is this? How is this like? Give me this. Give me this repo. Open repo. View source code. Okay, so there's a renovate in there. There's... What is this Docker file doing? Nothing. Entry point, output with summary. So it's using a template. Maybe I could look at their template. That might be cool. This is Apache 2 license, so yeah, I can pick this up. Unable to write result, unable to encode result, unable to execute supplied template summary, executing this match by severity, can't evaluate field counts by... Okay, so, you know, AI lied to me. So I'm going to do this one. Let's copy the raw and edit this puppy down. All right, so try it again, try it again, try it again. I need some music. No, I didn't mean to do that. Close. Close. Quit. I meant to open Spotify. Now we're talking. We've got output, people. It's still a lot. Now it's just a matter of getting that template. Because we should really rely on the template to do this inside of gripe. We really shouldn't be counting things manually in shell scripts. So all right, here we go. So this is just outputting, this isn't totals. Ah, look at that. That bottom line, that's all we need. Total. All right, so I'm going to take out these. I think I can comment out or take out these print statements. Thanks, Conrad. See you soon. Yeah, so let's edit that template, and we just want that total. We should probably... All right, we'll do the template over here. All right, so if we do quiet, oh, see, it's zeros. Oh. Okay, so if I delete that crap out of the template, I guess it's doing a count in the template. Okay, it's adding. What if I just do that? If it passes over, it's not printing anything, I don't think, there. We got to be getting closer. We got to be closer. Hey, if you're just joining me, today I am building off of the workshop we did yesterday. If you're not a part of my community, you can get on the Discord above. There's 25,000 DevOps people in there, just focused on DevOps, talking about DevOps, containers, cloud native, Kubernetes. It's all up there. If you're interested, there was a workshop yesterday from ChainGuard and I. We spent weeks building out this demo of exactly what I'm calling silent rebuilds. So pitching the idea that, hey, maybe you want to watch about this. This is about how to get CVEs out of your images, how to get your images. I guess maybe not so much how to get CVs out of your image. That was a byproduct. We actually spent a lot of time talking about taking images and migrating them to smaller base images. But the real focus here is that even if you make the most perfect image in your life and it has 0 CVs in it and you can't see any vulnerabilities for any of the scanners because they don't exist in there because you're so good at making images, Docker images, container images, that's only today. In 2 weeks, it might have one. In 4 weeks, it might have one. If it's got a base image of Alpine or Ubuntu or Debian or any of the common underpinning OS distributions that we all use in a lot of our dependencies for containers. If you did that, those are going to get vulnerabilities over time. So some companies, they just have mandates of saying things like, no container shall ever exist in production for more than a month without being rebuilt with upstream changes. Like they just sort of time block the potential for vulnerabilities over time and say that nothing can run longer than this because at that point, surely there's going to be a vulnerability. We assume that there will be vulnerabilities in 30 days. So you may not have that policy. And that policy is what I call a brute force approach to security, where we just constantly do things without regard for why. And that's fine. I'm not judging that. If you can approach that style and you have the level of automation in your company and your team, then that's great. That's awesome for you. A lot of us, we can't necessarily do that. We have things that maybe need to run more than a month. We have certain things that can be updated quickly, other things that have to run for a long time without being updated. That's unfortunate. But what I want, my goal here is that for you to know that there are better images for you to choose. Doesn't mean this isn't about switching from one base image to another. It's about knowing if your base image has changed. If you choose to run on Python Slim or Python Alpine, if you choose to run that, how do you know when there's a newer version of that image? Most of us, we know when there's a new version of Python. Turns out that's not enough. That doesn't take account what I'm calling silent rebuilds. And silent rebuilds are something that happens on every official image that I'm aware of, whether it's Docker Hub or wherever you're getting your image. And if I'm going to prove it to you, look at what this looks like. If we just take the Nginx image, it's a pretty small image in comparison to a lot of others. But if you pin to any one of these versions that are late, some of these later versions that are more recent, each one of these lines is that image is getting rebuilt in the background without any tag changes. It happens without you knowing it. I don't know it. You don't know it. We don't get an email. So if you were to deploy Nginx 1.27.5 on any given day over these 57 days, you might have gotten the old version, the newer version, the newer version, the even newer version, the newer version, and then the newest version. And you can see CVE totals here that change over time. We don't know why these things are getting rebuilt. You can go and look in repos and find open source PRs that talk about why, but we don't actually have the time to do that. Who has the time to do all that? We're not going to be reading PRs of the reasons for why images were rebuilt upstream. We just won't have the time. So we've got to automate this. We have to have checkers that go in and check. Is there a new digest? If so, give me a PR to approve. I need to know that there's a change, and this is what it looks like. If you just implement one of these tools that my repo will show you, it will show you in the open source what it looks like to change from one SHA hash to another without the image tag ever changing. This gives you the best of both worlds. This gives you extremely deterministic, guaranteed bit-by-bit identical images in all your clusters. But it also allows you to have the automated checks daily of the most recent build of that image so that you can be certain that everything you're doing, you're testing on the same image, you're running production on the same image. If your developers use these Docker files or these Compose or Kubernetes files, they will be using the exact same build. And everyone's moving forward in the lockstep of the exact build of that image. You might be rebuilding upstream yourself because you maybe have golden images and you're building those in a different repo. That's what I've done. I've worked with teams in the past. We do DevOps where we design a set of golden images and we customize and slim them down and get them very custom to just the workflow that our devs need. That image gets rebuilt all the time it doesn't always get rebuilt for security reasons. It might get rebuilt because I changed something in a GitHub action workflow. It might get rebuilt because I changed a README. It doesn't actually always mean security bonus, security feature, CVE really. It doesn't mean that. So you don't actually know why. You just know this is latest. This is newer. I should probably be running newer. One of the things in this repo that I wanted to do that we didn't get to do this week is, other than all the examples and documentation, of which I have a very long README that explains a lot of this stuff. I'm going to put this in chat for you if you're just joining me. So this repo gives up some documentation examples, explains this problem, gives you some demos of how to fix this problem. There's at least 3 different tools you can use to fix it, and get regular checks every day about whether your images are getting updated. That way, all of your downstream stuff, your clusters, your Kubernetes, they will all be able to know, at least you'll be able to run the latest version, and you will know as a human, hey, just like I have dependencies for my app, I have dependencies known as base images. And these base images, we can see here, like updating these images, updating this image from one SHA hash to another. This one updates from one version to another. Most of us know about tag version updates. We know that that happens. So these tools can detect both. And they'll tell you, okay, we're updating from, on this particular Docker file, we're going to update from .1 to .2. And from this one, we're going to do from .0 to .2. And you can see the changes in the files. And look at that. It's smart enough to pin to the SHA hash so that it guarantees you the exact version, even if the developer or the sysadmin or ops person accidentally forgot to digest, because you always want digests. We have the technology now that we don't need to avoid digest. They don't really add a lot of complexity as long as you're automating. So this stuff automates it in my repo. You can see all these examples. This repo is only a week old, so it's not completely finished, not completely done. What I'm working on today, which I've been here for, what are we streaming at? We're streaming 2 hours and 50 minutes right now. So if you're just joining me, we've been streaming almost 3 hours. And what I'm working on is we are down in the weeds, but what I want is to take this up a notch. I want this automation to tell me when it gives me that PR. I want Gripe or Trivy or Sneak or whatever your Docker Scout, whatever your scanner is. I want your scanner to go and check the old and the new. I want to know the diff, not of the image itself, like the diff of the image, but the diff of the CVE count. It's just one of many things. Like you could technically do a diff of what files have changed in this image. You could do that. I don't know that that's that useful. I care more about security updates than files upstream that have changed in Nginx. I don't really care that much about that. It's an interesting thing, but I don't know that my developers or anyone would actually be reading that stuff. But what they would read is if my PR says your CVE count will increase by 10, and 2 of those are critical if you merge this PR. Like imagine if every PR had a consequence area where it was like the security implications of this PR will affect you in this way. And so the basic 101 functionality of this scenario would be I scan my image of the upstream, and then basically the Git repo I'm going to try to, or the Git branch I'm going to merge into. What's that one? And then what's the one in my head that I'm suggesting? So this feels like it was supposed to be very simple. We are beyond simple right now. We are in 300 lines of bash hell. And one of the things I figured out is with Gripe, we can use Go templating. So right now, I think we got it. Okay, so now let me do this with a -Q. So what I should see if this works is when I do this Gripe scan with a custom template, it's only going to output totals. And what I want is I'm going to want it to output totals in JSON. Otherwise, it's going to have to do string. But if I can get this to output in JSON, then what I can have my shell script do is We have a shell script. And this is basically a GitHub action to run gripe against git diff changes and detect the image change upstream. Because now that we're using digest, we can be certain which exact image we're coming from and which exact build of the image we're going to. So we've got a from and to, and we can tell the diff. And, you know, right now it's 399 lines of bash script, but eventually maybe this turns into a Go binary. I'm not really sure what I want to do with it, but for now, we're just trying to get this thing to output something reasonable. So for now, we're outputting it as a string, and man, I would rather print this as JSON. Someone know how I can easily, do I have to just go into this template and like type out JSON syntax? Is that really what I got to do? So down here, we don't need that. We just need down here CV totals. And if I just wrap this in some, what is the, let's see, what is the output? So if you're curious about this stuff, ask questions in chat. If you're curious about vulnerabilities and Docker file building and GitHub Actions, like these are all the places that I spend my time. If you didn't know, I've got a new course coming on GitHub Actions. You can find that over on my website over there. There's links in the description. I'm building a GitHub course. I have very popular Docker and Kubernetes courses. They're all in the description. You can get coupons for them or get on the waiting list you will then get a discount coupon for. You can do all that below in the description. But this is part of some of the tooling that I want to put in the advanced sections of my GitHub Action course, because quite frankly, I think people run into these problems as they're implementing containers and GitHub Action automation and DevOps tooling. They run into problems because they want to deploy things and do cool things, but then everything's got vulnerabilities in it. So then they have to talk to the security team and say, well, maybe it's okay if my image has 1,000 vulnerabilities. For example, and the image we're scanning right now is a Node image, and we're picking on Node, and we're using a non-slim variant, which is going to have tons of vulnerabilities in it, which, you know, you should never use that in production. But where is my JSON? Okay, so JQ head less. So so I might be able to just do this right here. Actually, if I'm doing this in JSON, then I want nothing but JSON to be in the output. So I don't know, do I need to escape? Okay, so this counts. All right, so let's leave that there. Let's go back over to our codex. I don't want this at all. I want to delete this request. I have built a gripe Go template to create a custom output that should be easier for us to use. Right now, it just prints totals as a string out. output. I think we also need to change, let's see. Our shell script, I think we need it. I'm going to help the AI a little bit. All right, gripe scan right here. So we're doing a queue, we're doing a JSON. What we actually want, gripe scan. Okay, old and new are, okay, cool. It's actually templated this. This is good. This is good. So the only thing we need to change is, oh, I see. It's logging the command and it's actually running the command. That's fine. So we're going to do a -q. And then we're going to do, what's the command exactly? Template, file. Oh, I think it's template. Output is template and file is summary.tmpl. Yeah. All right, so it should just output the data. All right, so it's going to read that. And then I have built a gripe Go template to create a custom output that should be easier for us to use. Right now, it just prints totals as a string output. But I'd like you to edit that file and change, what is that line, 31? The output on line 31 to output small JSON, output as JSON text. So it can easily be parsed by JQ to get the CV totals in a more way. The benefit of this approach is so that the shell script doesn't need to add up values or even see the full gripe JSON output. You'll notice I've edited the bash script to run the updated gripe commands that use the file. Go! All right, we're going to wait on that for a minute. I hope it got the right command. Maybe that's over here. Where did I run that command? Was this over in, were we doing this with Google? Yeah. O template T. Oh, I said F. Shoot. Script. Hopefully that doesn't up. Okay, so it's editing the script at the same time. Okay, so it's fixing the script so it will parse this correctly, at least the output. I hope that didn't mess it up. All right, if not matches, print. I hope it's not doing this dumb. Don't be dumb, AI. Don't be dumb. Nobody likes you to be dumb. Oh, is it? It's being dumb. That's dumb. That's dumb. Okay, so we're having to escape. Okay, okay. Yeah, print F inside of a Go template. I don't know if that's the right way to do it, but it's changing it back. That's okay. I can fix that. Codex has only been working about 50% right today, which is pretty on par with any of these. You done? You done? All right, you explain it. Updated the gripe summary template to image structure JSON. You can rerun. Okay, can we? All right, let's see if it has anything to do with reality. And I bet you it failed because it gave wrong gripe commands. Yeah. That's a T. That's a T. Let's try again. Try again. All right, I'm going to let that run. And up here, what could go wrong with running two gripe scans at the same time? Nothing going wrong. Nothing my CPU can't handle. All right. Show me results. Show me. Show me. Now we're talking. Now we're talking. All right, let's compare those. 1149, 832. 1149, 832. 46. Nope, that's wrong. Unless it's literally changed in the last few minutes. 40 and 6. 42 and 6. 151 and 36. This is so confusing. Unknown. 738, 721. These are all these numbers are completely different. How can the totals 455, 346? I mean, these aren't even in the realm of accurate. I wish I could look in. What I need to understand how Gripe determines its totals. Am I going to have to go look at the source code? Is that what's it's going to take? Total 832, low, medium, high, critical, unknown. Okay, so I think the template file is at least good. This I do not like. If not, matches. I only have to assume that this is part of the problem. Let's go look up Gripe. I'm just curious. Gripe. Maybe I should have just looked at this at the beginning. Gripe templates. The folder contains a set of helper Go templates that you can use for your own reports. Feel free to extend or update the templates for your needs. Be sure to contribute back to this folder any new templates. This template mimics the default table output of Gripe. There are some drawbacks using the template versus the native output, such as unsorted, duplicate rows, no, won't fix logic. As you can see from the above list, it's not perfect, but it's a start. Produce a nice HTML template with a dynamic table. You can also modify the templating filter to limit the output. Is that what my template? It says high, medium, negligible, low, medium, high, critical. And this is saying there's an unknown. So critical, high, medium, low, unknown. Low, medium, high, critical. Oh, it's got an else. Add unknown. I feel like that's kind of janky. Low, medium, high, critical. But it seems like there's a status of unknown. So instead of unknown, yeah, and then else. If there's an else, I want to know. There we go. Thank you, AI. That is an appropriate response. I almost feel like that's maybe a debug output thing, but... And these... Let's keep the case the same. And then up here we define negligible, low, medium, high, critical, unknown, total. Do we add up total? So we're adding to total. All right, let's see how that looks. I really want them to just give me the template for how exactly they put it out in the summary. JUnit. Print it in Markdown. Print it in table. So when I do a gripe output, if I do quiet, I think it prints me out just the summary. Or not. That's not what I expected. Oh, we want JSON. Okay, maybe I don't want the quiet. I want it to file. I'm going to do that. Oh. No, that's not what I want. I want... All right, that worked. The totals didn't change, though. So if I did that, say 15D. 15D. All right, 832. 832. Critical 6. Critical 6. High 106. High 36. So what is happening in there in my evaluation? I mean, I have this unknown, maybe, what if I take off with the Q? High. How is it getting that number? Medium is different as well. Low is different. And 305 unknown. And I have 0 unknown. I wonder if it's a case issue. Is there simply... All right, this is what I'm going to do. I'm going to print this out. End. Severity. %S. All right, this is going to blow up, but scanned for vulnerabilities. I'm going to search for that text. Handle vulnerability scanning started. A lot of negligibles. $832. Maybe I should print out total. Actually, I did have the correct total, right? 832, 832. Okay, so it's seeing all the rows. It's funny that they have 305 unknown, which I have 0 unknown. But medium 82. Yeah, see, they have a lot more mediums, and I don't understand how they're... By severity. What if I search for that? Can I have a special character in search? Yeah, search for that. Vulnerability matcher. Fixed, ignored, dropped. Don't think I'm going to be able to figure this out in their code base today. I mean, I could just, I mean, the non, part of me is like, well, I could just have it read this text, but I really don't. I really don't want it to just read and search for strings. That's not ideal. And it seems like this summary data cannot be outputted in JSON. So the minute you output in JSON, you're up to yourself to do all this. Branch leaf. If only Eric or somebody was around to help me. I wonder if there's an issue, or let's see if there's a community. Join our community. Calendar, agenda. Discord. Discourse. Not Discord. Surely someone has tried to create a template that will give them totals, and they're probably wondering how the totals are not the same. Summary should respect filters, allow configuration timeout. The Anchor Slack, there's a Slack. Dan! It looked right for sure. I mean, really what I'm asking for is, how do I create a template that gives me the exact numbers that the output summary gives me? Template. Add more views into gripe results. Gripe JSON serializes some Golang structs. We would be interested in providing some query flags like fields and filters of subset Gripe's output. We'd like to add JSON schema document to Gripe and add some structs whose purpose is to be the models used to serialize the output as part of this. To auto-generate a template that mimics a default JSON output and adds a static analysis step that checks that the template needs updating. I like that. I like that. I like this too. I want this to happen. Let's make that happen. Ability to apply a template off a previously generated. So if I went back to their templates, artifact name, artifact version, vulnerability ID, vulnerability severity. So they're using the same values I am, right? Vulnerability severity, yeah. So I feel like I need to give them this example. Okay, so this works. This gives me the output I need in JSON. Negligible, this is basically going to error out. Get, and then actually did the script work? I'm assuming it does. Git add. What have you done? No. No. Incorrect, sir. Incorrect. Your script has been broken again. Actually, I want to dash template summary queue. Queue, oh, template summary, okay. Before totals. Oof. That was a bad. That's ugly. Hope it figures that out. I should have used single quotes. Please don't break everything. Please don't. I've committed, right? Yeah, that's fine. All right. Who's in chat? Who's here to watch about security and gripe scans and CVE totals in Docker images and GitHub actions? If you have any questions, throw them in chat. I'm probably going to wrap it up here pretty quick. I've been on streaming. I've been streaming 3.5 hours. So probably going to take a break. As long as it doesn't. Oh, is it casing? Okay. Gripe is now omitting the capitalized JSON summary you showed, and the script understands it. Outputs a consistent JSON object. Teaches to find case insensitivity. Yeah, convert numeric strings to numbers. Yeah, and default safely to 0. The rest of the script continues pulling the totals. Okay. So you say, AI. So you say. And we can get rid of that. Let's look at the actions. Ooh, okay. 40-6. All right. 42. So the numbers are still off. 151 to 36. Total 1149 to 832. I mean, the totals. I think the total's right. So I'm going to chalk the rest up to some weird internal thing that I'm going to have to ask someone about. Improved CVEs by 317. All right, this is good enough for today. What I'd like to do is make this more conversational, and then, well, this total's great, but in the summary of the job, but people don't normally go into the job to look. So what I'm thinking the next change will be is after it prints this summary, take that summary, feed it to an AI that will then, for the pull request that causes that job, it will throw in a comment that says, here's the latest. And basically the idea is that it's going to update that comment each time. I do that today for Docker images and Docker image versions. It wouldn't be a big deal for me to do that that way. When you're looking at the PR, you know your status, you know how well it's doing right now. All right, I like it. Book it. Let's go. What do we got? Git diff. All right, git add summary scripts. All right, the coup de grace right here. This should auto run. By the way, if I just run the script, yeah, usage scan, Dockerfile diff, base head summary file, scan Dockerfile from line changes between two git refs and report CV deltas. It's good enough. Okay, it's running gripe. It's running the second gripe maybe, or the first one. It's running the first one. Oh. All right, summary. Here's the moment of truth. A day's worth of work. Comparing this, change Docker files. We don't need both of these out. I need to clean this up later. Before totals, after totals. I don't need that either. That's repetitive. That's pretty dope. That's pretty dope. Improve, reduce CVEs by 317. I think this is useful, at least as a V1. I don't even know what to call this. Dockerfile diff scan. All right, let's look at this. So I have the scan. It's always going to run. Dockerfile diff CVE scan. Yep. That's good enough. Ready for review. Do I need to rebase? Okay. We don't need to do that again. Done, son. All right. Now, every time I put a PR into this repo, I will get an action that runs called Dockerfile diff CVE scan. And why is that running? I only wanted it to run on pull requests. I don't think we actually need that anymore. Dockerfile diff scan. Oh, it's still got this garbage in there. Scan Dockerfile base head. Yeah, I think there's a problem with that. I don't think that should run when I merge a pull request. Yeah. All right. Well, that wraps up this very long stream today. If you were at all here for any moment and you happen to see the end of this, then thanks for sticking around. I live stream on Thursdays usually. We have other events and everything planned. There's a calendar now that I haven't actually released yet, but I need to get that out there of events that are happening in my community. If you want to jump over here, this is our DevOps Discord server, 25,000 people in there. They're not all chatting at the same time, but there's tons of channels, people talking about containers and Kubernetes and DevOps and agentic DevOps, which is my new thing this year. I have 2 podcasts that have been around for years. Well, one of them has, and one of them is new this year, called Agentic DevOps. I have courses. I have all sorts of content for learning container and automation, specifically around Docker, Kubernetes, GitHub Actions, of all that stuff over on my website right there. And I will see you on the next live stream, probably next week, probably next Thursday. So like and subscribe, smash that button so that you can get notified when I go live, and you can come check out, ask questions, and see what my new guests, which I have often, my new guests, are talking about and what we're learning. See you next time.